All right, let's get right into it. Imagine you're a detective, but your crime scene isn't a city block, it's the entire universe. And the missing person? Well, it turns out it's most of the universe itself. This is the story of the cosmic manhunt for dark matter. To check out this number, 85%. That's a huge number, right? Well, that's how much of all the matter in our universe is, well, missing. We can't see it, we can't touch it, it doesn't give off any light. We only know it exists because we can see its gravity messing with the stuff we can see, like stars and galaxies. It is, without a doubt, the universe's biggest open case.
So the big question is, what is this stuff? What is this dark matter? Well, scientists have been on the case for decades, and believe me, they've put together a pretty wild lineup of suspects.
All right, so let's officially open the case file on what is, no joke, the universe's greatest mystery. We're talking about a cosmic crime scene where the evidence is literally everywhere, but the culprit is nowhere to be found. It's a detective story on the grandest scale imaginable. For decades now, astronomers have been seeing things that just don't add up. It's kind of like seeing footprints in the snow, but there's nobody there. You see these huge galaxies spinning way, way faster than they should be. So fast they should fly apart. Or you see light from distant stars bending as if it's passing by something massive. But there's nothing visible. These are the gravitational footprints, the biggest clues we have that something huge and invisible is out there. So this kicks off the manhunt. And I mean, we're talking about a global, high-stakes race to figure this out. Physicists have their list of potential suspects, right? And these aren't people, they're hypothetical particles. And the traps they're building to try and catch one, they are absolutely mind-blowing. Okay, let's bring in our first suspect. Suspect number 1. This one's been the prime suspect for a long time. Goes by the name WIMP. So WIMP stands for Weakly Interacting Massive Particle. And listen, for years, this was the leading candidate. And here's why. It's something so cool that physicists actually call it the WIMP miracle. The math just worked. When they calculated how many of these things should have been created right after the Big Bang, the number was a dead-on match for the 85% of missing stuff we're looking for. I mean, come on, that's too perfect, right? It almost felt like the case was closed before it even started. But here's the catch. How in the world do you catch a particle that's basically a ghost, that almost never interacts with, well, anything? You have to get clever. You go deep, deep underground to escape all the background noise from space, and you build the most sensitive trap imaginable. And then you wait. You just hope a WIMP happens to wander through the Earth and, just once, bumps into your trap. The head detective on this particular case is an experiment called Lux Zeppelin, or LZ for short. This thing is the world's most sensitive dark matter detector, buried almost a mile underground in South Dakota. And what is it? At its heart, it's a gigantic, super pure tank of liquid xenon. That's the trap. It's just sitting there in the dark, waiting for that one tiny bump from a passing WIMP. So the big moment arrives. LZ runs its most sensitive search ever. And the verdict comes in, and they've found absolutely nothing. Zilch. Not one single definite WIMP. Now, that doesn't mean the WIMP is innocent. Not completely. But it does mean the walls are closing in. Our prime suspect is running out of places to hide, and honestly, the case is starting to go cold. But then, and you can't make this stuff up, the investigation takes a wild turn. Turns out LZ is so sensitive that it started picking up something else entirely. It started seeing neutrinos, these tiny little particles that are streaming out of the sun's core. Now this creates what scientists are calling a neutrino fog. It's like trying to find someone in a thick mist. It could be totally hiding a real WIMP signal. So it's this incredible breakthrough, but it's also a massive new headache for our cosmic detectives. Okay, so with the WIMP lead cooling off, investigators are pulling up the file on our second major suspect. This one's a totally different character, much lighter, much more elusive. Meet the Axion. Now, what's so fascinating about the Axion is that nobody invented it to be dark matter. That's not why it exists. It was actually dreamed up way back in the 70s to solve a totally different problem in physics, something called the strong CP problem. The fact that this particle, which solves that problem, also just happens to be a perfect dark matter candidate, well, that's a huge deal for physicists. It's like you're investigating a robbery, and your main suspect also happens to solve a completely different cold case. You start to think, okay, maybe we're onto something here. So you can't hunt for an Axion the same way you hunt for a WIMP. It's just too sneaky. Instead of waiting for it to bump into something, you have to try and force it to show itself. The plan is to use these ridiculously powerful magnetic fields, and the hope is that when an axion passes through, the magnet will basically trick it into turning into a little particle of light, a photon. And a photon, that we can see. So our detectives have three main angles of attack. You've got helioscopes that look for axions coming from the sun. You've got lab experiments trying to make them from scratch. But for our manhunt, the big one, the main event, is something called a haloscope. This is the tool designed specifically to listen for those primordial axions from the dawn of time that we think are floating all around us in the galaxy's dark matter halo. And this is where things get really cool and futuristic. You have new experiments like Mad Max popping up, and they're building a whole new kind of haloscope. This thing uses this really clever design with a bunch of special discs inside the magnet. What do? They basically act like an amplifier for that super faint signal of an axion becoming a photon. It's like they're building a brand new type of microphone to listen for the universe's quietest whispers. But hang on, what if we're thinking about this all wrong? What if dark matter isn't just one rogue particle? What if it's part of a whole other hidden reality, a shadow universe with its own rules? This brings us to our third and by far the most exotic suspect on the list, the dark photon. Okay, so stick with me here. The theory goes that maybe there's a whole dark sector out there. It has its own matter, its own forces, the whole shebang. And the dark photon, it would be the particle that carries the dark light force over there, just like our photons carry our light. And here's the kicker. It could be a bridge between their world and ours. Through a process called kinetic mixing, it could kind of flicker in and out of our reality, giving us just a tiny peek behind the curtain. So how do you find that? Well, the investigation is moving on two main fronts. First, you've got experiments that are basically just listening, waiting for a dark photon to pop into our reality as a normal photon we can see. Second, you have the brute force approach, smashing particles together in giant accelerators and hoping you create a dark photon for a split second and then see the evidence it leaves behind when it vanishes. All right, so after looking at all these suspects in all these investigations, where are we? What's the status of this cosmic manhunt? Let's check the case files. Okay, case file status report. The WIMP, still a suspect, but the case is getting weaker. Our best traps are coming up empty. The Axion, this lead is heating up big time. We've got brand new tech coming online that's going to check all its favorite hideouts. And the dark photon, this is a fascinating new lead. It's not just about one particle anymore. This could blow the case wide open to an entire hidden sector. And, it's really important to get this. Even when these massive, expensive experiments find nothing, that's not a failure. It's actually progress. Every time they look somewhere and the suspect isn't there, it's a huge clue. It tells the detectives, okay, don't look here anymore. It crosses a possibility off the list, narrows the search, and lets them focus their energy on the leads that matter. So yeah, the culprit is still out there. The case is still open, but the hunt is on and it's getting more intense every single day. The traps are getting bigger, smarter, and more creative. The real question isn't if we're going to crack this case, it's just a matter of when. And which of these strange suspects will be the one that finally unlocks the biggest dark secret of the universe?